Hello guys, welcome back to our channel. In this latest lecture, we are going to talk about Spark. What is Spark? Features of Spark, architecture of Spark, and Spark submit command, and internal processor when we submit a Spark job. So let's deep dive into what is Spark. Spark is nothing but it's a compute engine, open source, general purpose, in-memory, distributed computing engine. It is used for big data analytics and machine learning. So let's understand one by one in the definition. The first one is open source. When we want to install or use this Spark in our systems, we need not to pay any single rupee to use this Spark. So it is open source. It's available in the internet. Anyone can download from their browser and install in their laptops. So that's why it became an open source. Second one is general purpose. It can plug and play with any storage account and any cluster manager to run the Spark applications. Third one, in memory. In memory means it stores the intermediate results in memory to reduce IO operations, IO read and write disk operations. It improves the performance. Whenever we require the data, then automatically it goes to its memory and fetches the data from there. Next one, distributed. When we load the data in the Spark cluster, the data will be distributed among the nodes by partitioning the data in the form of tasks. Now let's understand what are the core components of Apache Spark. Spark Core, Spark SQL, Spark Streaming, YAML, and Graphics. Spark Core is the older version which deals with the RDD and low-level programming. It was difficult to write the code, but it is type safe, and it no it is not using Catalyst and Tungsten optimizer. And second one is Spark SQL. It enables the users to write the code in SQL, which is very easy, and it uses Spark Catalyst and Tungsten optimizers, so and deals with the data frames. So it is very user friendly to run anyone in the Spark SQL. Third one, Spark Streaming. It deals with the real-time data which is coming from Kafka or any Kafka Flow means or any other things. Fifth one, YAML. This is used to run machine learning algorithms. And fourth, last one is graphics. Graphics is used to run the graphs related data and analytics. These are all about core components of Apache Spark. Next one, features of Spark. First one is fast performance. Fast, we already discussed that it uses in-memory computations. So when the data is loaded in the Spark, we already discussed that Spark uses in-memory computations. While doing the computations in the Spark job, the intermediate results are stored in memory of its Spark. So whenever the data are required again, it automatically fetches from the memory. It reduces the IO cost and improves the performance of the job. And next one, easy to use. It supports multiple languages like Java, R, Python, and Scala. So and SQL also. Everyone can use everyone can use their comfortable language which they want to write. Next one, unified engine. In single engine, everything is involved, like machine learning. It handles machine learning, structure streaming, as well as graph related data. It handles all the type of data in single unified computing engine. Next one, lazy evolution. Lazy evolution means in our Spark job, we write multiple transformations and actions and complex code, right? It won't execute until the action is triggered. So this is called lazy evolution. Next one is fault tolerance. Spark is fault tolerant because of this lineage graph. Whenever the RDD failed or destroyed by doing some operations, it's automatically repaired from its previous RDD. By using the lineage graph, automatically Spark will apply the transformations in its previous RDD to get the latest RDD. Using lineage graph, Spark becomes fault tolerance. And next one is runs everywhere. It runs with any cluster manager like Yarn, Mesos, Kubernetes, anyone. This makes Spark flexible. And Spark supports multiple data sources like MySQL, SQL, Azure, AWS, Cassandra, so many. It supports multiple data sources. It has rich libraries. Like we already discussed in the previous slide, it supports machine learning libraries, Kafka libraries, so many. Already we discussed this distributed computing. The data which is stored in the Spark cluster automatically distributed among the worker nodes and loaded as a partitions, and each partition has a 128 MB of data. And like the last one is dynamic resource allocation. Means based on the user code, Spark automatically go through the code and it decides how many what amount of resources it requires. Based on the decision, it's dynamically allocate resources to the job. Let's go to the next slide. Key components of Spark architecture. We already know Spark follows master-slave architecture. Here, master is the driver and slaves are worker nodes. Let's understand each and every component in the Spark architecture. Spark driver program. It is responsible to schedule the job and it converts the user program into the DAG as well as stages and then tasks, and it gives tasks to the executors. Once we submit the Spark job to the cluster, then driver initiates Spark session and it negotiates with the cluster manager for the resources. This cluster manager is responsible to release the resources to run the job. And third one is executors. This is the actual processing happening. Executors run each and every task which is received from the driver. Next one is worker nodes. Worker nodes are used to have the executors in it. The last one is tasks. Tasks are nothing but it is a small unit of work which is assigned by the driver. Now let's understand what happens when we submit a Spark job to the Yarn cluster manager and the deployment mode is cluster. Here we have two deployment modes. First one is client mode and second one is cluster mode. In the cluster mode, the driver runs inside the Yarn cluster manager along with the application master. We'll discuss step by step in this slide. When we submit a Spark job to the Yarn cluster, then Spark contacts with the Yarn resource manager and it requests to launch its first container to launch the application master along with the driver. Once the Yarn resource manager allocates a container in one of its container in one of its node managers, it launches its application master and the driver will run inside this inside this node manager. Then application master driver will connect with each other based on the user code in the driver. Driver automatically creates tags and stages, right? So based on the requirement analysis, application master will again connect with the resource manager to ask extra resources to run the code. Then based on the application master negotiation, resource manager will release more resources in its node managers on each worker node. Then Spark executor starts inside the containers. These executors will register with the driver and based on the task, driver share each and every task to the executors. The executors will run the task which are assigned by the driver and based on the schedule of the driver, executor performs the task and results are again sent back to the driver. Once the driver get results from the executors and it informs the application master to about the job status. Once the job is completed, application master informs the resource manager to terminate the resources from the cluster. Then automatically resource manager shut down its containers from the cluster. This will happen when we submit a Spark job to the cluster. In the cluster mode. Now let's understand what happens in the client mode. Yeah, one more thing. You may get a doubt like this is happening entirely in the Yarn cluster. Then where is the Spark cluster? So when we use cluster mode, then automatically The Spark runs inside this yarn by dynamically arranging cluster inside the yarn cluster manager. Now let's understand the Now let's understand what happens when we submit a Spark job to the client mode. When we submit a Spark job to the client mode, to the client machine, the driver program initializes its Spark session and it connects with Spark master, and this Spark master will negotiate with the driver program to know the details about resources. Once it got the information, then automatically Spark master will release the resources, will assign the resources in its worker nodes. Once the resources are assigned to the worker nodes, then automatically driver share its tasks to the executors. Once the computation is completed in the executors, the results are sent back to the driver. Once you get from the results, Spark releases its resources. This is happening in the client mode. This is the entire process which we are doing in the client mode. Spark submit starts the driver program on the client machine. Driver contacts masters for resources. Master assigns executors on worker nodes. Driver sends tasks to executors. Executors perform computations. Executors send results back to the driver. This is the entire program happening when we submit a Spark job to the client. Next one. This is a sample Spark submit command which we included some basic parameters. Here we write to the Spark hyphen submit, and then hyphen hyphen. Here we mentioned class name, like which class we want to execute, and and here we mentioned the deployment, the cluster manager, and then deployment mode. Here we included memory and number of executors required to run this program. Now let's understand how to initialize the Spark session. Here I'm using Databricks community version. So first I'll start this cluster. It takes 1 minute time. Yeah, it's attached now. The Spark has inbuilt is already included in this Databricks. So here we write the code to initialize the Spark session. Before going to initialize, we need to import that from pyspark.sql import Spark session. Let's run this first. It ran successfully. So the Spark session is imported successfully. Now let's try to access the Spark session using Spark variable. Spark session builder local one app name example and then get or create. This is used to initialize. This is used to access the Spark shell. So builder, it is used to build the Spark application. Here in the next master local means, here I'm not using yarn cluster manager. I want to run my program in a locally. So here I mentioned local, and here one means is the number of executors. It should be always greater than 0. And next one is app name. It is used to give the name to our application. And last one is get or create. Get or create means it gets the Spark. If the Spark session is already existed, then it gets from there. If it is not existed, then automatically it creates a new Spark session. This is all about the today's lecture. In the next lecture, we'll discuss more things about Spark schema, how to define the schema explicitly, and run run some programs on top of it. Thank you. When we want